session on a block diagram reduction. In this we'll continue with our block diagram reduction rules. A very important associative law for a summing point. Here the order of the summing point can be changed if two or more summing points are in series. Important. If two or more summing points are in series, then the order can be changed. But very important is the output should remain the same. Let's see with a given condition. In the given condition here, we are having two summing points, summing point 1 and summing point 2. So this is second summing point. So input here is R1 and here the another input for this summing point is R2, but it is a negative. So the output here coming will be at this particular line will be R1 minus of R2. This will be input for the second summing point, and there will be additional input of plus R3 into this one. Hence the output which is coming out from the second summing point will be R1 minus of R2 plus R3. Now if we happen to change this summing point from here to here and this summing point from here to here, is it possible, and whether there will be change in output? Let's see that one. So we happen to change the summing points from here to here, that is we brought here R3 and we replaced this one R3 with the input minus R2. Let's see. The input here is R1 as usual. Here the addition of input will be R3. So the signal which is coming out after summation is R1 plus of R3, and it will be getting summed with a negative signal minus of R2. Then the output will be R1 plus R3 minus R2, which is same, which is similar to this one. So hence there is no much considerable output change if we are going to have this one. So this is what we call it as a associative law. Associative law for summing point is applicable only to summing points where there is directly connected to each other. Directly connected to each other means like this, directly connected to each other. That is, there is no intermediate block. So in between this connection there should not be any intermediate block. There cannot be any intermediate block like this, nor it can have any takeoff point in between. Neither we can have any takeoff point in between. Okay, so then only this rule can be applicable. Next important is block or important. Next important is eliminating a minor feedback loop. So this was a very important rule in case of a block diagram algebra. Let's see that one. It includes the removal of internal simple form of loops as shown in the figure. So if we are having one summing point, one forward block, one takeoff point and one feedback block, and we are having feedback signal plus or minus, and the input for this particular type of a loop is R of S and output from this one is C of S, then we can write this one into one single block as like this. In the block we can give the input as similar to this one, R1 of S and output C of S, and inside the block in the numerator we are going to suppose to write the forward block, that is G of S whole divided by 1 plus 1, whatever signal we are having, no, that signal either plus or minus then product of the forward block G of S and the feedback block H of S. This is what you have to write. This can be written inside the block. Eliminating such a minor loop, if a summing point carries only one signal input and one signal output, it should be removed from the block. Next, shifting of a summing point before the block. This is one of the important rule in this block diagram algebra. So in the shifting of a summing point before the block or behind the block, let's take one figure. Here we are having a summing point. This is a summing point, and there is a forward block, and we need to shift this summing point before the block, that is here we want. Before that, let's see what is the output coming out from the existing block. So input of this block is R, input of the block is R, and the output from the block is product of R and G, that is Rg. At the summing point we are having the signal Y. It is a positive signal, so the output will be C is equal to Rg plus Yg. When we are shifting the summing point behind the block or before the block, what will happen? We are going to bring the block before the block. We are going to bring the summing point before the block. Here, when we are bringing, we are going to add a block in reciprocal of the forward block in series with the signal. Now, thus, while shifting the summing point before the block, here we bring the forward block, this forward block reciprocal in series with the summing point. So the modification what we do here is we bring the block here, additional block, that is reciprocal of the forward block 1 by G with the same signal Y. Let's see what happens here. R will be the input, the output here will be Y divided by G. Summation of this one with R will yield you R plus Y divided by G. The input through this one will be through the G block. The output here will be coming as Rg plus Y of G. Next, let's go to one of the important rule, that is rule number 5, shifting a summing point before the block. Now we have to shift a summing point before or behind the block. Let's consider a system as shown in the figure. In this figure we are having a summing point, this one. It has to be shifted before the block. It has to come to this one. So before coming to the output, let's see how the output is coming here. So R multiplied by G, so it will be Rg. Y getting summed with Rg, here it will be Rg plus Y. So just Rg plus Y, Rg. Okay. Now, what is the need here to shift this summing point before the block? So whenever we are shifting the summing point before the block, what alteration we have to do? So we have to bring an additional block, that is the same as the forward block but in reciprocal, that is 1 divided by G in series with this particular summation point. So the input here will be 1 by G, the signal will be Y as it is. So here the output which is coming here will be Y by G. It is getting summed with R. So output from this R block or from this summing point will be R plus Y divided by G multiplied by this G. So output will be C of S equal to Rg plus Yg. Thus, while shifting a summing point behind the block, that is before the block, adding a block is required, having a transfer function reciprocal of the transfer function of the forward block before which the summing point has to be shifted, and making sure that it is in series with all the signals that are at the summing point. This is what you have to take it. Next, we are having the rule number 6, that is shifting a summing point after the block. So what we have done in the previous case, that is shifting of the summing point before the block, here we have to shift the summing point after the block. Now shifting after the block is also called as shifting the summing point beyond the block. Let's consider the figure. Here we are having the block R, here we are having the block. So the block is next important block diagram reduction rule is rule number 6, that is shifting a summing point after the block. Now we have to shift a summing point after the block or beyond the block. Let's consider a system as shown in the figure. In this system we are having a summing point here. It needs to be shifted after the block. The block is this one, G. So the input for this summing point is R and Y. Hence the signal coming out from the summing point will be R plus Y, because it is having a positive input. This is also positive. Going through the block, the output here will be G multiplied by the summation of R plus Y. So this will be the output. When we shift the block in after the summing point, when we shift the summing point after the block, what we get? So this summing point is shifted in front. So here an additional block has to be brought here, that of the forward block, that is G block. In the previous case we were doing the reciprocal G block, and we are supposed to get the output So in a shifting of the summing point after the block, the modification what we need to do is we have to bring a block in series with the signal the same as the forward block G, and the input for this one will be Y, and it will be getting summed at the forward summing point. Let's see what happens with the output. R is the input. When the signal passes through this forward block G, the output will be RG. So this will be a positive. And the output coming out of this G block will be Y into G, because it will be product of signal Y and a forward block G. Then after summing, it will be coming as RG plus Y of G, which will be as R plus Y product of G. So it will be same as this one. So the output remains same. Hence, while shifting a summing point after block, adding a block having a transfer function as same as that of the block after which the summing point is shifted. It should be in series with all the signals at that summing point. Next, we are going for the rule number 7. There may be some conditions where we need to shift the takeoff point either before or after the block. Let's take the condition of shifting a takeoff point before the block. Here we are considering a combination as shown in the figure. At this particular takeoff point means we are taking away signal out of from this particular point. So if suppose we are not taking off, so what will be the input for this one? For this block it is R. So output here will be C is equal to RG. And if I am tapping here and taking out signal Y, so what will be the output of from the signal Y? What will be the signal Y will be? Y also will be equal to R into G. If suppose I want to shift this takeoff point from this end to before the block here, then also I require the output from Y to be R into G itself only. Hence for that I have to modify. So the modification will be bringing a transfer function block as of the same forward block in series with the takeoff point. So from this takeoff point in series I have to bring a additional block of the forward block G itself only. Then what will be the outcome of this one? R will be here, and when I am tapping here, here also it will be R, here also it will be R. But when R passes through this block G, the output will be Y is equal to R into G, and the output here also will be C is equal to RG. Thus, shifting a takeoff point behind the block or before the block. Here need is add a block having a transfer function same as that block behind the takeoff point. Whatever block we had behind the takeoff point, that has to be shifted in series with all the signals which you are going to take off. This is what we need to do. Next, in rule number 8, we happen to do shifting of a takeoff point after the block. Here let's consider the combination. The takeoff point has to be shifted after the block, that is in front of the block. Here we need to shift it. Let's see before changing. So R is the input signal, Y will be equal to R of G, which you are going to take it out from here. So if I am not shifting here, so let me erase this one. So output here will be the product of R which is coming here input R multiplied by G, C is equal to RG. When I am shifting the takeoff point after the block, then there should be a additional block, that is the inverse of the forward block or reciprocal of the forward block in series with the output which you are going to take here. So it will be 1 divided by G. Here we can see there, so when you are shifting here 1 divided by G, the output which is coming here will be RG it will be getting multiplied by 1 divided by G, and this G and this G cancel, the output will be remaining Y is equal to R, which is similar to here. Here the output for this one will be C is equal to RG, which is also same. Thus, to shift a takeoff point beyond the block or after the block, add a block in series with all the signal, that is reciprocal of the transfer function of the block whichever is there beyond the takeoff point, which is to be shifted. So whenever you are shifting, remember the forward block and its reciprocal has to be shifted. Need not touch this block. The blocks of these one will remain there itself only. Next, in block diagram reduction, we have two critical rules. Let's go through this one. The rule number 9. Here we have a typical problems where we have to shift a takeoff point after a summing point. Till now we have done takeoff point of shifting after a block, but here we are going to do this shifting after a summing point. Let's consider the combination. So here we need to shift this takeoff point after this summing point. Before that, let's see what is the condition here. R1, when you are taking out here x as a variable, it will be equal to R1 itself only, and here it will be R1. So at the summing point we are having Y as a signal, so it is plus or minus, so output here will be C1 equal to R1 plus or minus Y. The same output result has to exist when we are going to shift this takeoff point after the summing point. Let's see how it can be done. So here, while shifting the takeoff point in front of the block, we have to bring one additional summing point, and the previous summing point will be there itself only. It will be having from this one we have to add one more block like this. This is where we have to do the correction, and here we are going to shift the takeoff point. This is how we will work, and this will be the summing point, that modification. The signal here which will be coming will be positive, but the input signal from Y, whatever we are going to give, will be the inverse of this one, that is minus to plus. So if you are giving a plus and minus, here you should give minus and plus. If you are giving a positive signal, here you should give the negative signal. If you are giving negative here, you are going to give the inverse of that positive. And the output which will be coming out here will be X. That is what you have to do the modification. This is the modification which will be coming. This block, the additional block will be coming as a modification. The important thing here is adding of a new summing point and change in the input signal for this summing point. Let's see the result. R1 is the input, y plus or minus is the input for this one. Output from this one will be R1 plus or minus y. So when this is tapped, the output for this one will be the same one, R1 plus or minus y. Okay, when we get a signal from this here, this one will be y, which is minus plus. So this one. So what will happen? This will get summed here. So during summation, R1 plus or minus plus or minus y gets summed with minus plus y, which both gets cancelled, and output here will be only remaining R1, which is what was in the previous condition. That has to sustain. That is what we are going to get here. So to shift a takeoff point, after us the this is what you have to remember in this condition. So addition of one summing point in the diagram. Next, one more critical rule, that is rule number 10. Next, one more critical rule, that is rule number 10, shifting a takeoff point before a summing point. Let's consider the combination shown in the figure. Here we are supposed to shift the takeoff point before the summing point. Okay, so let's see the condition here before changing. So R1 input, y input, so here the output will be R plus or minus y. When you are going to take out of this one, x will be equal to R1 plus or minus y. The variable which is coming out here will be same, whatever you are going to. Here also it will be same, c is equal to R1 plus or minus y. The same thing has to prevail in the modification. So whenever you are modifying the takeoff point before a summing point, again we have to bring one additional summing point here, and in this case there is no need to change the signal. One additional summing point you have to bring it here. Okay, so here we are going to get the summing point here. Here I am drawing and showing what is existing, it is here. So here it will be having plus, and the signal has to be tapped from here, so this one, and same signal has to be given, that is plus or minus, no change in sign. And you can take away signal from here. This is what. So let's see here, R1 will be the input. So here also it will be, when we measure the signal here, it will be R. When we measure here, it will be also R. So here what is going here, it will be y input, y plus or minus y. Here whatever it will be going, it will be also y plus or minus. So when it sums here, so comes out R1 plus or minus y, and when it is getting summed here, so it will be c is equal to R1 plus or minus y. So this is how you are going to modify when you are going to apply the critical rule. Critical rule should be applied whenever it is very much essential in the problem or you are not able to proceed the problem without this modification. That time you have to apply. Okay. So let's summarize and understand the procedure to solve the block diagram reduction problems. So next we have to know the procedure to solve the block diagram reduction problems and steps involved in solving the block diagram reductions are going to be explained now. The step 1 is to reduce the blocks connected whichever are in series using the rule number 1. Next step, reduce the blocks which are connected in parallel, rule number 2. Third, reduce the minor internal feedback loops. If any loops are going to be created which is having a forward block and a takeoff point and a feedback block with a summing block, then it can be reduced to a single block by applying the minor internal feedback loop. Then step 4, as far as possible try to shift the takeoff point towards the right, okay, towards the right, and summing points towards the left. Unless and until it is the requirement of the problem, don't use rule number 9 and 10. Those are the critical rules. So whenever the problem is in a crunch situation where you are not able to proceed, that time you have to apply this rule number 9 and 10. So that will be explained. Step 5, repeat the step 1 and step 2, step 3 process using the takeoff point shifting or summing point shifting methods, and try to simplify the problem. Lastly, using standard transfer function of a simple closed loop system, obtain the closed loop transfer function in the ratio of C of S by R of S for the given overall system. So till now we have studied about the modeling of physical system, analogous system, and in this session we have studied about the block diagram algebra, and more importantly we have understood the general representation of feedback control system, transfer function, and rules of block diagram algebra. Next we are going to know about the problems associated with this one and how we are going to obtain a closed loop transfer function. Thank you. For any details, contact me at my email ID, that is naveen.kalal@canaraengineering.in. Have a nice day.